When trying to determine where a power series converges, there are two kind of weird cases that crop up, and I'm going to show you one of each of them. In example A, we have n factorial over 2n factorial. This is give us some practice. And in B, we just have an n factorial on top and 2 to the n on bottom. So in both cases, we start out by using the ratio test. So for A, we're going to let L equal the limit as n goes to infinity of, add a 1, absolute value. Add a 1, you get n plus 1 factorial. Add a 1, you get 2n plus 1 factorials. And add a 1, you get x to the n plus 1. Then you flip and multiply, so you have an n factorial on bottom, a 2n factorial on top, and an x to the n on bottom. That's not bad to simplify, at least for the x's. So this is the limit as n goes to infinity of, pairing up like terms, we've got our n plus 1 factorial on top, which we know we can write as n plus 1 times n factorial, because that's the next number down. So that's our n plus 1 factorial. We've still got our 2n factorial, and we've got our x to the n plus 1. Then we rearrange on the bottom. We've got our n factorial first, and then we write out our 2n plus 1 factorial. Well, we know that 2n plus 1 in parentheses is 2n plus 2. So it's going to be 2n plus 2 times the next guy, 2n plus 1, which doesn't line up with the one on top, so we've got to keep going, times 2n, which does line up, so we stop and put our factorial, times x to the n, throw an absolute value, and keep the fraction bar. When we take this limit, this is the limit as n goes to infinity. You can see that the n factorials cancel, and the 2n factorials cancel, leaving us with an n plus 1 over 2n plus 2 times 2n plus 1, and then in absolute values, x, because there's only one x left and it's in the numerator. So when we look at the limit, again, we're not letting x vary. X is a constant number, like a 7, we look at the limit as n changes. X is 100, you look at the limit as n changes. X is constant, look at the limit as n changes. Since the degree of the polynomial on top is 1, and the degree of the polynomial on bottom will be n squared, will be degree 2, we know that the limit of this term is 0 no matter what number x is. So this is 0, which equals L. We know by the ratio test that we converge whenever L is less than 1, and 0 is always less than 1, so converges no matter what x is. That's the kind of longer way to say it, but that's the way that I think really helps a student pay attention to what's going on, really keep it straight. This limit did not depend on the x, but we got a 0, which means it converged no matter what the x was. That tells us that even though L is the number 0, our radius is infinity, and our interval of convergence, IOC, is negative infinity to infinity. This is a series that no matter what x you plug in, it will converge. That's one of the weird cases. When L is 0, R is infinity. Notice these are inverses of each other. There's a reciprocity happening here. The other case, B, we're going to do the same thing. Let L equal the limit as n goes to infinity, using the ratio test, of n plus 1 factorial, x to the n plus 1, over 2 to the n plus 1, times flip it and you get 2 to the n factorial, x to the n. Notice the x's are always pretty boring, it just does the same thing. That's the limit as n goes to infinity of compare the factorials, so n plus 1 factorial, n factorial, 2 to the n plus 1, and x to the n plus 1 over x to the n. That is now L is the limit as n goes to infinity. Well, the factorials canceling we'll write out once more to make sure we've got it. You write the n plus 1, you write the next term, and you notice that that lines up with the one on bottom, so that's where we throw our factorial in. We've got a 2 to the n on top and a 2 to the n plus 1 on bottom, so there's one more 2 on bottom. And then the x's cancel down to having only one x on top. Now, the factorials cancel, so this gives us the limit as n goes to infinity of n plus 1 over 2 times the absolute value of x. So now we're curious again, what is this limit? By the ratio test, we want less than 1. So we're going to keep x steady. Pretend x is a fixed number. We're taking the limit as n goes to infinity. And as n goes to infinity, n plus 1 goes to infinity. And dividing by 2 doesn't change that fact. So this limit is infinity. Just like before, that means that no matter what x was, it's going to diverge. But there's one weird caveat. So just like before, you're going to flip it and say, well, that means our radius is actually 0, so there's this backwards nature here. So that's what gets most students, is you see an infinity and you think it converges everywhere. But if L is infinity, then that means it diverges a lot. Okay? So, that tells us our radius is 0. I said it's kind of weird because it doesn't mean it doesn't converge anywhere, it diverges everywhere. It means it converges only at the center. So our radius is 0, and our interval of convergence is the point. In this case, the center was 0. And if you want to see why, look back at the previous video that talked about why, no matter what, if you plug in the center, it will converge. So those are the two weird cases. Remember, they just seem backwards. If L is 0, then that means R is infinity because you converged a lot. If L is infinity, that means R is 0 because you diverged a lot. So I hope that helps keep it straight.